Hi, I was just trying a little experiment here to see if I could tell the difference between these two black balls. They're both the same size. They have the same mass. They're made of the same material. This is my happy ball. Bounces very nicely. This is my sad ball. And I'm trying to figure out what's the difference between them. I'll tell you the difference later. Today, we're going to talk about the nature of science. Science is our way of knowing how the world works, dealing with how things happen, why they happen, what causes them. So let's try a little. To be a good scientist, you don't have to be a super brain to be a scientist. Just ask a question and look for the answer. So here's what we're going to do. We're going to start out with a little observation. I have in this some water. I'm going to pour it into this cup. Now then, remember I poured it in this cup. Now, which cup is the water in? This one right here. And if you said this one, you would be correct. So now I've poured it into this cup. Now which cup is it in? If you said this cup, again, you would be correct. All right, one more time. Now remember, I poured it into this cup. Now which cup is it in? Yeah, you would say the middle, right? Guess what? The water has vanished. What happened to it? So there's the question. Observation. He poured water into that cup. Question, what happened to the water? Well, before we got started, I had placed some stuff in there that turned the water into a gel. Now, let me say this. This is the same stuff that made diapers super absorbent. So what you can do, if you want to play with some of this, get some unused disposable diapers, rip them open, pull the lining out, stuff it into a Ziploc bag, zip it up, shake it real hard for a couple minutes. That stuff that settles down in the corner will be this water lock that you can play with. And trust me, it's not hazardous, so there's no problems with that. Has anybody really missed not having any snow this year? Well, I found some other stuff here. Simple white powder. I'm going to pour some water into it and let it go. And guess what? I have instant snow. It looks like snow. It's not quite as cold as snow, but it is wet. And the very same stuff that they used when they needed to make a snow scene in the movies. So we can just brush that off, and it will dry out and revert back to a powder. In fact, there's a very famous person, Steve Spangler, who found 55 barrels of this stuff. He didn't know what to do with it. So what he did was he started playing around with it and found out that it would make instant snow like this. He started figuring out how much water it would hold, decided that since his hometown, which is Denver, had not had any snow, they were going to give someone a snow Christmas, a white Christmas. And the only logical person that they could think of was his brother. So he went out, he mixed some of this stuff with water. He went out to his brother's house, covered it, snow. There was snow on the fences, snow on the mailbox, even snow on the houses. And they let it sit there for a few days. Gave Denver a chance to come out and see the white Christmas. The legal department for where Steve was working at the time came back and said, all right, time to get rid of this stuff. So he had his crew out there. They've got brooms, they've got shovels, they're cleaning all this up. But what they hadn't realized is during the time that it was sitting there, some of it was drying out and they couldn't get it out of the grass. So the next time it rained, poof, instant snowstorm. Yeah. All right. So that's an observation. And again, you don't have to be a super genius to be a scientist. You just have to follow the scientific method, series of logical steps in answering a question. First one. Make an observation. Your observation with the cups. You saw me pour the water into the cup. That's an observation. Now, people tend to think that an observation is strictly things that they see. That's not correct. An observation is anything that you encounter or anything that you experience with your five senses. You could see it, you can hear it, you can smell it, you can taste it, you can feel it. That's an observation. It's any one of those five. For example, you saw this artificial snow. Now, if you were here, you could feel it. A real smell. Yeah, it tastes pretty bland. Doesn't make any sounds. But those are all observations that we can use. All right. So we've made an observation. Step 2, ask a question. Remember, I said science is a way of knowing how our world works, why it does what it does. If you've ever gone out and asked the question, why is the grass green? Why does the sun rise in the east and set in the west? Why does the wind blow? Those are all questions that you can answer as a scientist. You can set up something to do that and to find the answers. Some of the brightest scientists really weren't any better or any more intelligent than you. Isaac Newton, Albert Einstein, they were just as intelligent as you are. The only difference is that they had more experience, more things to work with, but they asked the questions. So once we've asked a question, next thing we need to do is conduct some research. Maybe your question's already been answered. Let's face it, Isaac Newton asked the question, what is light? And he went and did some things to find out the nature of light. And that was how he realized what the light really is. But he's answered the question, what is light? All right, so now let's say for an example, continue on our example, number 4, your research did not answer your question. Set up a hypothesis. This is a question that you are looking for the answer. And generally, a good hypothesis is stated as if, then. If I do A, then B will happen. if I take a balloon and I've got some special powder in there, and I'm going to take some of this, pour it into this beaker, add just a little bit of water here. Now I'm going to pour it into this flask. Now, my question is, if I stretch this balloon over the mouth of this flask and dump the powder into there, what will happen? If I stretch the balloon over the mouth of the flask, if I dump the powder into it, what will happen? There it is. So the balloon is inflating. That's the answer to my question, if then. If I dump the powder into this liquid, then the balloon will inflate. Now we've got our hypothesis. Next thing we want to do is an experiment. And that's basically what I've done here. I said, what would happen if I dumped the powder into the balloon, into the liquid? What would happen to the balloon? And I've conducted that experiment. So now we've done our experiment. We're going to analyze our data. What does this show us? This shows us that that is causing some sort of chemical reaction. It's generating a gas. So now we've got our analysis. Next thing we want to do is come to a conclusion. All right, so if I dump that powder into the liquid, the balloon will inflate. That's my hypothesis. If then. We did the experiment. We analyzed it. The balloon did inflate. Our conclusion, my hypothesis was correct. But we're not finished yet. There's one more thing we need to do. And this is not recognized as a part of the accepted scientific method, but it's something that I feel is very important. Report your results. Tell someone what it is that you did, how you did it, why you did it, and what results you got. If you do the experiment but you don't tell anybody, why do it in the first place if it's going to be something that's going to help people? Now, we've got another little experiment here. I've got some more water. I have 2 rocks. Hypothesis. Or question, observation. I've got water, I've got rocks. Question. What will happen to the rocks when they fall into the water? Well, the obvious answer is they're going to get wet. We've done some research. We haven't found an answer to our question, partly because we don't know what type of rocks we've got. Hypothesis. What happens to a rock when it falls into a lake or a pond? It goes to the bottom, correct? Little experiment would drop this one in. And it does. It falls to the bottom of the beaker. Now this rock is a little bit different. So our hypothesis might be it's going to have the same effect. It's going to drop. drop it in the water, and look at that. That rock floats. I'll do it again. That rock is floating. And yes, it is a rock. So we've done our experiment. We've analyzed this. The conclusion that we can come to this is that this rock that went to the bottom of the beaker is different than this rock that floated. I know that you have probably seen this happen. I take a plastic ring. I'm going to balance, very carefully balance a hex nut on top, if I can do it. Come on. There. Now then, if you've seen these videos before, you have an idea of what's going to happen. I'm going to hit the ring. The ring is going to pull out of the way. This hex nut should drop into the beak or into the bottle. You ready? Uh-oh. Something didn't go right. All right. Here's what's happening, and I know this from personal experience. When I hit the ring like this, that ring is going to compress, it's going to squeeze up, it's going to throw the hex nut off. If I want that hex nut to fall into the bottle, I take my finger and just hook it right here and pull it out of the way instead of hitting it. And it will happen every single time. Another question that you might ask is, where did those 2-liter pop bottles come from? Well, believe it or not, it comes from this. This is called a preform. And what they will do is they will take this, put it into a mold, heat it up, force air down in there, and blow this up just like a balloon to make their 2-liter bottle. You notice I've got a second one here that's different. This is 2-liter. This is a 1-liter bottle. Now, if you can find something like this, ask your parents about this. Ask them if they remember the lava lamps from the 70s. What I've got here is I've got a layer that's dark green. I've got a layer that's clear. And when I turn it over, notice how it flows. Notice that the dark green is always staying at the bottom. So here's another question. What in the world is going on that would cause that? Any ideas? Any clues? All right. The dark green is simply water. And I've added some food coloring to it. The clear up here is vegetable oil. It is less dense. It has less mass per unit volume than the water. So it's going to float on top of the water. That's why oil floats on water. That's why it's so hard to put out an oil fire if it's over a lake. I've done my observation. Those layers will stay separate. I've asked my question, why? I've done some research, and I found that scientists who have done this have told me water is more dense than oil. Well, all right. So again, I may not believe it. My hypothesis is that if I put oil and water together in a tube like that, the oil will separate, the water will flow to the bottom, the oil will float to the top. I've done my experiment. I analyzed my data. I've come to the conclusion that those people who told me this were correct. And now I'm going to report it. Actually, I'm going to take this and set it up so that I can show people. Isn't that cool? All right. Another thing that you can do. Fact check. This box says that it is fortified with iron. Does that mean that it's actual iron or some sort of iron compound? Well, you can open a box of Total. You can put it into a plastic bag like this, add some water to it, mash it up, 2 or 3 minutes, make a big mash out of it. Then take this very strong magnet and you can pull the iron out of that cereal. They actually put iron shavings into that cereal. Now, let's see. I've shown you this. This. You've got food coloring in water here. Now I've got some of these tubes, and I've got different colors in here, and I can hold them up to the light and see the color. I can mix the colors. I can match the colors. I can do whatever I want to with them. We mentioned scientists like Isaac Newton, Galileo comes to mind, Albert Einstein comes to mind. These are men that all they did was ask a simple question. Then they went looking for the answer. And again, they are no more intelligent, no smarter than you are. All right, I told you at the start, thank you. I told you at the start that I would explain the difference between my happy ball and my sad ball. Again, they are made of the same material. They're the same size, the same density. Then why does this one bounce and this one not? It's all in the way that they are made. The happy ball comes together and it forms polymers. Those polymers are long chains of molecules all stretched out, and they form them like this so that when the ball hits the ground, they compress and they spring back. Compress and spring back. Compress and spring back. That gives my happy ball its bounce. The sad ball, on the other hand, doesn't bounce because instead of being mashed like this, the polymers are like this. So there's no bounce, there's no give to them. So that's how this ball does not bounce. All right. And, oh, I know one more thing. I know that these balls have the same density because I've measured the density. That was one of the questions. Do they have the same density? Density is equal to the mass divided by the volume. So if you can measure the mass, not the weight, but the mass, and calculate the volume, then you can calculate the density. Difference between mass and volume, or mass and weight, is the effect of gravity. That's all I have for you today. Thank you for joining me, and I hope to see you next time.